Hello and welcome to this video tutorial from BlenderCookie.com. My name is Jonathan Williamson, and today we're going to tackle a topic that's going to be a lot of fun and that I think most everyone will enjoy, whether you've played with it or not, and that is cloth simulation. For those of you that don't know, Blender 2.5, and previous versions actually, has a full built-in cloth simulator. It's very similar to the soft body physics that Blender also has, except that it's geared directly towards generating more realistic cloth, be it denim, cotton, leather, even rubber or silk. It has all these different presets in it that allow you to create the different materials with relative ease without having to know exactly what all of the different settings and such do. So we're going to do a fairly simple example of this, and that is basically just a cloth draping around a sphere. But then we'll take it a little bit further and look at movable objects, collisions, and so on. So to get started, let's first just go ahead and delete the default cube, and you will notice that I'm using the official Blender 2.53 beta. So I'll just hit X and delete the default cube. I'm going to hit 7 to go on a top view and hit 5 to switch out of perspective mode. And then I'm just going to hit Shift A and add a UV sphere mesh object. I'll just use the default number of segments and rings on this and the default size. But then the only other thing I'm going to do is just hit smooth for the shading, and that'll just give a better presentation. Now I'm going to go ahead and hit Shift A to add another mesh object, and this time I'll choose plane. On this plane, let's go and hit Tab to go into edit mode, and we're going to scale it up 2 times. We'll just hit S2 on the number pad and then hit enter. And what we want to do is go ahead and subdivide it, because the way that the cloth simulation works is basically letting each vertex fall along gravity, collide with other objects, and so on. So the more vertices you have, or the higher the poly count, the better the resolution of your cloth. Now keep in mind that the higher your poly count, the higher the simulation time will take. So let's just hit W and subdivide, and then we're just going to go ahead and switch this up. We'll just maybe do 10 cuts. The maximum number right there should give us a decent amount for now. And let's hit Tab to leave edit mode, and then we'll just hit G and G, Z to lock it to the Z axis, and then hit 2 to move it up just 2 increments. And this way it's positioned above the sphere. With the cloth simulation, since it's related to the physics engine, it takes into account real gravitational forces such that it'll just fall down right along the z-axis. So the way we can go ahead and test this is if we go over to the physics buttons, let's just add a cloth object. And now it's using the default settings. In this case, it's using silk. And if we just hit Alt-A, we can actually see the simulation play back in the viewport. But you'll notice that it doesn't really do anything. You know, everything is just falling straight down. It doesn't collide with any objects. There's no variation in the cloth. All the cloth has the exact same weight, so it falls perfectly flat. But we can go ahead and fix this. And the first thing I want to do is let's go ahead and make it collide with the sphere. Now, with the physics simulations, to make objects collide, you have to define that object as a collision object. So we can just select the sphere, and then just click Add Collision. And the default settings will be fine for now. And the only ones that refer to the cloth really are these soft body and cloth settings, or soft body and cloth right here. The outer determines how close to this surface a cloth object needs to get in order to deform or to collide. And then the interface is within the inside of the mesh. So now if we go ahead and hit Alt-A, we can immediately see it fall, and it falls on top of the sphere, continues to fall, and then it starts to slide off and then continue falling down. So this is very, very cool. But, you know, it's still a little boring. For one, we really don't have much interest in here. Well, something that we can do is we can either hit Tab to go in and subdivide it again, or to give us more control of optimization, let's go ahead and just add in a subsurf modifier to this subdivision surface, and let's move it above the cloth object. So this way the subsurf will be applied first, and then the cloth object will be applied, so that the cloth is actually taking into account all the subdivisions that have been added from the subsurf modifier. So now our simulation will take slightly longer to calculate, but which at this point it's pretty low res still, so it's still almost, well, not real time, but you can see we're playing about 8 frames per second. And so now we're getting a much better result. We go ahead and increase this again and improve it even more. And so this, having the subsurf modifier on here, rather than subdividing this instead, allows us to get more control on the fly. So if we just need to test a certain aspect of this, maybe the collision, we could go ahead and turn this down to speed up our simulation, or turn it up to increase the realism of our simulation. Now let's go ahead and set our cloth to smooth so that it looks a little bit better, and mess with a few more settings. First off, let's go ahead and take a look at the presets. So first we'll go with the cotton. And if we go ahead and play this, we'll see, we have something kind of like a t-shirt or something that you see a lot of very small wrinkles. It's pretty buoyant, so it bounces a lot, but it's just a very light cloth. Well, let's go ahead and switch this over to denim. Now we'll see a much stiffer cloth, so you won't see nearly as many smaller wrinkles. This is like what jeans are made out of and such. And so you see, a lot more, it's holding its form a little better. Now, obviously, it's bouncing up a little bit, and part of that is because of the height that it's fallen from. And as this goes along, you also notice that our frames per second has slowed down a lot. So let's go ahead and just turn our subsurf down a notch, just to speed this up while we're demoing this. Okay, so that's working fine. Well, let's now just check out the other ones. Say a leather. This will hold its form pretty well. So you can see it just kind of drapes over it. Then we've got our rubber, which is a very bouncy material, obviously. So it just kind of bounces all around. And then finally we have the silk, which is what we were looking at before. Well, this is all fine and dandy, but first off, let's do one more thing to improve the presentation of this so we can see it a little better. And that is just to go ahead and add in a simple grid pattern so we can really see the cloth deforming. Well, we can do this just by hitting Tab to go into edit mode, hit U and unwrap, and then let's switch over to the UV image editor. And I want to actually go into edit mode on this, so we can just hit this right here, and that will go ahead and switch it into edit mode, allowing me to see my UVs. And then we'll just click new image, and we want to check this UV grid right here. Well, now if I switch into, or if I hit in to go in my properties panel, scroll down under display, I can change this to textured solid. So now that'll go ahead and display that in the 3D view. But this grid is a little larger than I would like, so let's just go ahead and go back to the UV image editor, and we'll just maybe scale this down to, say, 0.5, or how about maybe just about 0.5, and that way it'll just be a little bit larger within our cloth. There we go. So now if we hit Alt-A, we can really see that deforming, and really goes to show how it's working. So it just also allows you to see a little bit more of the difference between the sphere and our cloth. Well, let's look at a few of the settings actually involved with the cloth. First off, we have the steps here, which is the quality of your simulation. The higher the steps, the better it will be, but obviously the slower it'll be. So if we go ahead and play this, we can see, and let's go ahead and just use just the cotton will be good. Okay, so we can see it play back, all fine and dandy. Well, if we increase the steps to say 20, first off, you'll notice that our frame rate drops dramatically, particularly once it starts to collide. Do note that collision objects add a significant amount of calculation time to your simulation. So the more collision objects you have, the longer it'll take. So you may not notice a lot here, but with the more complicated your mesh gets, and particularly as you get more and more moving objects or moving collision objects, the higher the quality, the better it'll be. But it does come with the downside that it kills your simulation time. So we're just going to go ahead and turn this down to 8, so just slightly higher than the default. Then we've got things like the mass, so the mass of the cloth material, the actual weight of it, the structural stiffness, so how well it holds its shape. You'll notice things like leather have a much higher structural stiffness than, say, things like silk, which has a very low structural stiffness. Then we've got our bending, so the higher the bending, the more big wrinkles there are, but less smaller. So if we turn this down, we see a lot of smaller wrinkles, but not very many big wrinkles. So on things like silk, we got a very low value here. On leather, we have a much, much higher value here. So really, we don't see any little surface wrinkles. We just see these big kind of form wrinkles. Then we've got things like springiness. So, how much dampening is there when it hits things? So higher the value, the smoother it is and less jiggling. So again, on things like leather, it's fairly high, whereas on silk, it's nothing. Then on rubber, it's also very high. Denim, it's pretty high. And so it's all based on the different materials. Then we have the air. So basically how porous is the surface? How much air friction is there? So on things like leather, you're going to see a lot, or let's see. Actually, I guess the air value doesn't change on any of the presets. But if you wanted something to say, has a lot of holes in it, so it lets a lot more air through, then you could go ahead and tone that down. Then our next thing is something that we're going to look at real quick here, and that is pinning. And what pinning does is allows us to basically define certain parts of the mesh that do not get collision or only partial collision. So for example, right here, it just drops completely. Well, what if we wanted to make something, say, like a window curtain? Well, currently, this wouldn't work very well. We could technically drape it over a pole, but then chances are, over enough time, it would just slide off the pole. So that's, really not what we're looking for. Well, instead what you can do is go and hit tab to go into edit mode. And let's say we want to just grab these two vertices. So we want these two points as if you're holding it by the corner of the cloth to stay in place. Well, let's go over to the object data buttons and add in a new vertex group. So we'll just hit the plus sign and we'll just go ahead and call this cloth underscore pinned. And then we want to click assign with 100% weight. And then what we'll do is go over here and in the pinning, first enable it, and then under the group, choose cloth underscore pinned. Now if we hit Alt A, you'll notice those two vertices stay in place such that, they don't move at all, they're not getting any simulation. Well, maybe you wanted this to be sliding down a wall, but it's kind of sticking to it. Well, then let's go ahead and say on this group, we'll just give the cloth, say, maybe a 0.5 weight and click assign. And now, if we hit A, you'll notice that it falls slightly, but it's still just kind of dragging along the corners and then bouncing back up. So this is very, very cool. And, while there's not very many examples or uses for that, you can definitely see how from time to time you might have the occasional case where you needed that. Or another way, or another use for that would say, maybe you've got a layered material. So maybe around the edges you have, the cloth is kind of folded back. Well, let's just go ahead and select all the edges here where maybe the cloth has been folded back on itself. Give this maybe a 0.1 weight and click assign. And now if you hit Alt A, those corners will be a little heavier or will have less simulation applied to them. And by the amount of weight, you can determine how much that is. Now note, anytime you change the weight, you need to click assign. So now you'll see how it's kind of folded back on itself. Now obviously in this case, it's like it's been held in place. So you need to play with that, but you can see how that could feasibly be used. Let's go ahead and remove everything from that group and go back and just apply our corner vertices to it. And again, we'll just apply it at 100% weight. And remember, if we now play this, it just falls down. Well, what about movable collisions now? Well, let's go ahead and let's just animate our sphere real quick. So what we'll do is let's just enable the record button here. We'll move our sphere right over like this, maybe to about here. And let's go ahead and jump up to, say, frame 60. So we've got basically 2 seconds of animation. And then just move it over here. And that'll automatically insert a keyframe. We can go ahead and turn off recording, zip back, and now just hit Alt A. And you can see how that works just perfectly. But this also starts to pose an interesting problem that we can start to see just a little bit, which now that we've played it, we can actually go ahead and pan through this. And as we get to right about, well, actually, I guess that it's not doing it in this case. If we made it a little bit faster, which, okay, let's go ahead and do that. So what I'm going to do is I'm just going to go ahead and go to frame 60, select my sphere, and hit Alt-I, which will delete that current keyframe. And then let's just go ahead and go back to frame 30, and we'll then move it over here, hit I to insert that location keyframe. And so now the sphere will move much, much faster. And if we hit that, actually, okay, it didn't quite get it. So we'll go ahead and remove that keyframe. And then let's go ahead and put it at, say, frame 40. Maybe that'll be just about enough. There we go. So there you can see what's happening is the cloth is intersecting with itself. You can really see this right in here. And obviously, we don't want that. We want it to be very nice and smooth and to collide with itself. So what we need to do is enable self-collision. So if we select our sphere or our cloth object, let's go over to the physics buttons. And under the cloth collision panel, we need to enable the self-collision. Now keep in mind again that the self-collision again increases the amount of calculation time. So once more, you're going to see your simulation slow down. And of course, the higher the quality, the slower it'll be. But if we play this now, you'll notice that it no longer intersects with itself, and so it'll bounce off itself. It can fold back on itself, anything that it needs to do to not collide. And we can maybe see this a little more clearly. Let's just say we grab these two two edge vertices and just slide them in to the edge here. Now, obviously you can see that when you do that, it messes up the simulation because it just goes haywire. So just go back to the beginning of your timeline by hitting Shift left arrow, and then let's play this. And so now you can see that it's no longer intersecting with itself, but it's folding over, no problem, and really working quite nicely. Let's go and hit Tab and just undo that in edit mode. And obviously now you'll see that it went haywire again until it flipped back to the beginning of the animation once more. Now, just so that this repeats quicker, let's go ahead and change our timeline down to, say, 60 frames. So now we can just kind of watch this repeat over and over. Or maybe we'll go ahead and give it just 100. And now let's go ahead and look at just a couple more settings. We're almost done here. But let's look at, first off, is the cloth stiffness. So if you wanted to say, define your stiffness right here, which is basically, I guess here we go, your structural stiffness, this here, and then your bending stiffness, this one here. Maybe you don't want those to be the same all over. You want to use the vertex groups like we did on the pinning. Well, then you can just enable this and define a group. Say maybe we want the top bar here to be much more structural, then just assign a weight of, say, 7.75 or 1. Same thing with the bending. And so that allows you to further add some variety to the cloth and get more control. We're not going to worry about that for the time being. Same thing with cloth field weights. You can go ahead and say, do I want, maybe only partial gravity to affect this, such that it falls slower? I can go ahead and turn down all the force fields. I can say, maybe if I have some other things like if I have a wind, I can say how much wind affects it. And speaking of wind, let's go ahead and look at that. So currently, I'm going to set this back to 250. And you'll notice that, after our ball moves through, our simulation gets pretty boring. It just kind of swings back and forth. But maybe we want some wind to be blowing this. Well, let's just hit Shift A, add a force field, and wind. On this force field, you notice that it's basically an empty with several circular lines around it, pointing along the Z-axis. Well, currently, if we go ahead and hit Alt-A and play this, you'll notice not a whole lot happens. So what we're going to do is let's first hit Alt-R, Y, and 90 degrees to rotate it around the Y-axis, so it's pointing the same direction the ball is moving. We'll move it back along the X-axis, and then under the physics field, let's go ahead and turn up the strength, which you'll notice is being indicated by these, and hit Alt-A. Now you see this playing back, and then we should see, here we go. So you can see that it's no longer just hanging straight down, it's actually being affected by the wind. And if we go ahead and turn this strength up, you'll see it just kind of blowing through the wind right here. Well, that's kind of boring at the moment. So let's go ahead and do this. First, I'm going to go ahead and remove my sphere. Or actually, no, what we'll do is we'll just hit M and 2 to move it to another layer. And then hit Alt-A. And, we have a simple wind, but it's kind of boring. Well, so on the wind, wind doesn't blow in its solid force normally, unless it's, say, a fan. So let's just add some noise to this. And so now the wind will go in and out of the strength so that there's some variation. We can increase this a lot more. Maybe move it back along the X-axis a little bit more. We can increase the strength even more if we want, taking it all the way up until you can see it just blowing through there. So very, very, very cool. You can go ahead and increase the convert effector force into airflow velocity. Honestly, I don't have any idea what that does. I'm sure that there's some people that could tell you exactly what it does, but feel free to play with that. You can go and change the shape from a point, or a point or a plane. So I believe with the plane, it goes just that direction. With the point, maybe it goes all directions. I'm not positive on that. Not the right person to ask, but you can go ahead and play with it to see what you like. But then something else is, how about absorption? Well, let's go ahead and bring our ball back. So I'm going to go to layer 2 and then move this back. And on layer 1, let's go ahead and remove the keyframes from this. We'll just go to layer 40 and Alt-I, remove that, go back to the beginning, and then let's go ahead and just move the ball down right here. Now I'm going to go ahead and remove the keyframe on the beginning so that we can actually move it as well. Now if we play this, you'll see that it's kind of hanging off there. Well, actually, let's go ahead and move it up here. And what we want to do is on our effector, let's go ahead and change the collision to absorption. And so now collision objects will go ahead and block out the wind. Now you'll notice this has pretty much killed my simulation time, but if we were to go back to the beginning here, well, this is too slow to actually demo here while recording, but what it does is allows this wind to be blocked by our collision objects. And one of the things why this is taking so long is that we've got, as far as collision objects go, this is fairly complex. In order to get good fast simulation, something that you generally will do, at least when you have a full scene, is create very, very simple collision objects such that you have, just rough indications of a shape. So if you have a person, you would have just a very, very low poly kind of cage mesh that acts as your collision object that then is actually not rendered during render time, so that it's only basically just blocking that one thing. And this is what really allows you to kind of optimize your simulation to save some time. So that's pretty much it. That is an introduction to cloth simulation in Blender 2.5 Beta 3 or 2.53 Beta. Pretty simple and really, really enjoyable and works quite well. So with that, we'll just play this back one more time and maybe just make this a little more interesting. We'll just go ahead and move this over right about here and play that back. So that is cloth simulation in Blender 2.53 Beta.